And thank you all for coming. And I have two goals with this talk. And the first one is to teach you what I've learned about asyncio while writing a web framework using asyncio. And the second one is to introduce that web framework that I've written since PyOhio last year, where I saw a talk on asyncio, and I'm like, oh, I could write something using that. And let's just jump right in. My goal here is not to tell you what asyncio is or why you would want to use it, but rather how you use it, okay? I will say that it was introduced in Python 3.4, and so I'm only going to be talking about Python 3 in this talk. And we added a, or not we, Python added an asynchronous library, and that's called asyncio, and it introduces a lot of new terms. So you've got coroutines, event loops, protocols, transports, futures, StreamReaders, and writers, and it's a little bit intimidating. We're like, all right, what do I actually need? How do I actually use these things? And it's the docs I found helped more if you already knew what was going on and you wanted to use a certain function, how you use that function. So I'm going to explain how I interpret this and how I use them. And my target is really like, oh, I wish someone would have told me that earlier, like at a different talk. Mostly they just talk about why you use it or how it works. But so jumping in, what's a coroutine? So coroutines are the core of asynchronous programming. These are the functions that are actually running one at a time in the event loop. So they get added to, scheduled, and executed by an event loop. Keep in mind that they only run one at a time. So this is different than threads, where you have everything running simultaneously. And that can, if you're coming from that paradigm, because this is a different concurrency paradigm, you can think of like, oh, I'll do all this simultaneously by creating 5 different coroutines and they'll all be running. No, only one's going to be running at a time. So if you try to break your tasks into smaller pieces to run like you would with threads, you're making a mistake. You're just adding more overhead and complexity. Coroutines can pause themselves and then allow another to run. The event loop will schedule the next one if there is one. And so how do we create one? So right now in Python 3.4, you create one by using the asyncio coroutine constructor, and you usually just decorate that over a function that you've defined. So we have a function spam, and right, now it is a coroutine. It's interesting, though, and something that you might not realize is that spam now does not, if you call spam, you do not actually call that function, the contents of the function. What you do is it creates a coroutine generator that is given to the event loop, which will eventually execute the code. So asyncio actually has a function, asyncio.isCoroutine. And if you pass spam into that, just the word spam, it would say false. It would say true in isCoroutine function. So spam is actually a coroutine function. In the docs, it would say spam is a coroutine. This function is a coroutine. So that's one of those like, oh, wait, am I supposed to call it? Do I just pass in the word? No, you actually have to call it to get the coroutine object to give to the event loop, which we'll talk about in a second. So there's this coroutine. What is a coroutine? Is it the function that you've created, or is it the thing that is created by asyncio coroutine that gets added? It's totally a context thing. Once you figure out how these things work, then you can say, oh, I'm in the coroutine, meaning you're in the function, or I have to create a coroutine, which is calling the function, which returns a coroutine generator. So coroutines, and only coroutines, have the ability to yield from other coroutines. And in this case, yeah, so this is where those, wait, coroutines, you're throwing the word around a lot. So if you're inside the coroutine generator, you can yield from this other generator, and it eventually passes things into the event loop. But you don't care about that. Yield from has different, different meaning in asyncio than a normal function, conceptually. conceptually. Probably not on the actual language level, but yield from will block your current coroutine, say run this one event loop, it'll run that one until it's done, and then it returns the result, so you can say x equals yield from coroutine, and it'll work. So this both schedules it and blocks until the next one's ready. That's what I just said. This allows you to run asynchronous code without callbacks. So if you're coming from a Node.js or JavaScript background, you always have to have callbacks in all of your code, and managing these callbacks can be a pain, and you know that's true when there's like 100 different libraries that are made to try and fix this. Like, oh yeah, well, now we can make promises, and now there's a different way of when you have all these libraries to fix a language feature. It's probably bad, or not bad, but you want options sometimes. And the other cool thing about this is you can actually catch exceptions. So if you so you can put this yield from within a try block and then catch exceptions. Again, the coroutine or the callbacks in Node.js usually have the first parameter is an error, and then you have to check, oh, is this an error because the database is down? Is this an error because of this or that? Now you can just raise whatever exception you want, and if you don't catch that one, something else will. Cool. So yield from only creates and runs coroutines inside coroutines. If you're outside of a coroutine, if you're just in your normal program or a normal function, you have to call loop run until complete coro, and that will pause your function, run the coroutine, and then return the result. And that's one of those things that if you don't realize and you're trying to yield from outside of event loop, because that's how you get the result of a coroutine, you're going to have a bad time. And it's frustrating if you don't realize that. So that's why I wanted to say that. So the event loop, it's kind of a simple idea. This is the thing that actually executes the coroutines. You have this run until complete, which I just explained, will run the coroutine you give it. It may call others. It's not going to put that one in priority. Or you can create a bunch of coroutines, add them to the event loop, and then say run forever, and it will run all these coroutines that you've created. Coroutine generators that have been added to the event loop. This is the method you'd use for creating a server. You'd create your server coroutine, then say run forever, or multiple servers if you have multiple servers, and that way it'll run forever, or until you call loop.stop somewhere else in the code. You can call run forever after that, though. At least one of these must be called somewhere in your code to get it started. You can't just like create the coroutines, add them to the event loop, and then, oh, they finished yet, because you actually need to tell the loop to run them explicitly. You can have more than one loop at one time. You usually tell multiple threads. They can't be multi-threaded, so you have to create a new one in each thread if that's what you need to do. And there is a new event loop, and it's often handy to say set event loop right after that. Okay, futures. They're sometimes called promises in other languages or libraries, and this just allows you to set something in the future, set this to be some result. It behaves as a coroutine, so you can yield from it, and should be used for resources that have not been initialized. So if you have to create a database connection or something, it could just return a future that represents this database connection your code can run. And when it needs the database, you yield from that connection, and then poof, it's there when it's there. Okay, now tasks. From the docs, schedule the execution of a coroutine, wrap in a future. And so this is one of those cases. What's it in this case? Is it the coroutine? Is it the result of the coroutine after it's done? I'm not sure what it means, but the important part here is actually schedule the execution of a coroutine. If you create a task with with the loop. That loop gets the, actually gets the coroutine, schedules it, and it'll run eventually. So tasks get done with asyncio. You don't construct, you don't build a task directly. You either call asyncio.async with the loop as a parameter, or loop create task, where that's explicitly setting the loop there. And you still have to give task. Oh, I should also say task is a subclass of future. So everything that you get from futures you get with tasks, including yield from and run until complete. And this is the case where now you can call run forever because we've added these coroutines into it. And again, these are coroutine generators. So you have to call the function, it returns something, and that gets added. So before, in my spam example, you'd put spam and parentheses in there. OK, run in executor. This is something that I didn't know about until I was actually making these slides, and this is really handy. This is the exception to the rule. This is where actual simultaneous code can go. It spools up a thread for you, runs your code, the function that you give it, in that thread. At the same time, it returned a coroutine object to you, so you can yield from this while your code's running in the background. Often, this is actually what you want to be doing if you're like, oh, I want to make a bunch of tasks, but they're not tasks, they're threads. It's one of those naming things. Right, so this is great. If you're writing a library, this is how you would make it asyncio. So if you have some long math process, or you're image manipulating and you want that to run in the background in async code, you don't need to actually worry about setting up the threads to do that. Run in executor. This is how you call it. None just means use the default thread pool, and you pass it the functions and the arguments. This is a coroutine, though. So you have to be careful, because you can't just call run in executor. It's not going to run. It's going to return a coroutine generator, which you have to give to the event loop, which will then run it. So that's where you look in the docs and you say, oh, this is a coroutine. That's not just going to work. OK, so let's talk networking now, because that's usually where async I/O is the most helpful. So servers are created for you by async I/O. There's two methods to do that. One is create server, loop.createServer. It deals with transports and protocols, which we'll get to in a second. And the other method is async I/O start server. And that also takes loop as a parameter if you want to specify the loop that you want to run this in. And this deals with StreamReaders and StreamWriters, which we'll get to in a couple moments. Both of them are coroutines. So if you call loop.createServer or async I/O start server, it neither creates a server or starts a server. It gives you a coroutine object, which needs to be given to an event loop, which will create or start the server. It won't listen, though. You have to afterwards call run forever, and then that coroutine is listening in the background. So these are the kinds of things that you don't realize at first. But once you're told, it's like, oh, of course, no duh. OK, transports. I mentioned transports and protocols. Transports are really just wrappers around the socket. You can read and write to them. You don't want to subclass this unless you think you're better at writing a TCP protocol in Python than the people who do that. So we'll just skip that. So protocols. Protocols are the interface between your network and the network and your actual program. So you want to subclass async I/O protocol, and this is where your server code starts. Yeah, subclass this. When you call the loop.createServer, you give it a factory function that returns a protocol. So it could just be a protocol class name or a lambda or something like that. No arguments are provided for that, so keep that in mind. Upon a connection, so it runs init, and then it calls connection made with the transport object. And you can read and write from that. And upon data being received from the client, it'll call data received method on your protocol. Okay, StreamReaders and writers. So that was the other way of, if you call asyncio.startServer, you'll use these. These abstract away a protocol and transport. So here's an example of something you'd call asyncio start server. And this is actually one of the cases where you actually return the coroutine function, unless that's a bug. But I'm pretty sure that's how I wrote it. I wrote it correctly. And then that function gets called, creates the generator, and runs it in the event loop. So your coroutine that's another factory, really. So the factory, or the coroutine function. And you're given a reader and a writer, and these are basically files that you can read from and write to. Reading is a coroutine itself, so you yield from. It'll wait until the data is available. So this is just an echo server that reads a kilobyte of data and sends it back. Behind the scenes, asyncio has a StreamReader protocol, so it's literally like they implement a protocol that does the buffering for you and does the behind-the-scenes work for free, and that's nice. And it actually, start server actually calls create server in the background, so it's not doing anything magical. You can look at the source there. The transport's even available in reader under transport. Okay, and clients have a similar interface there where we have create connection and open connection with transports protocols. And of course, both of these are coroutines again. So if you call create connection or open connection, it neither creates a connection or opens a connection. It creates a generator, which will, upon given a event loop, actually call that. So you're writing a server. Which one do you use? You have these two options, and it's both have good or bad properties. So if you run create server, remember your object is getting called whenever incoming data is available. So this is more of a event responder. So if you have a lot of things going on that you're not sure what you're going to be receiving next, you'd want to use create server. Asyncio start server, right, gives you this this object that you yield from, and you can read and write to these objects. So think of them as just files. This is more of a passive process, the create server. This is more of an active process where you're actually trying to get data from a thing, and that's good. So I have some suggestions. Right, if your protocol is going to send data to other objects, like an HTTP parser or something like this, you want to use create server because you're notified of something happening. You can look at the data and then forward it to somewhere else. But you will have to probably manage your own buffers, so keep that in mind. Start server, if you have a single task, so if you're reading in an XML file and replying back with a JSON object or storing it in a database or something, you just want to get a file, read the XML document from it, and then do something with it. So I would recommend using start server for something like this. I also recommend not passing around the StreamReader objects because they could get lost and something could be yielding from when you don't expect it. So you could still get deadlocks, but you want to organize your code not to. Okay, so that was kind of my whirlwind tour of everything you should. This is how you use asyncio. And now we're going to talk about Growler. So at PyOhio 2014, at this very spot, actually, Brian Koslow gave a talk on a gentle introduction to asyncio, and I was sitting somewhere over there. And then after that, I was kind of like, I got the schemy fingers. Like, oh boy, like a whole new library that's available. Like there's, the space is totally open. This is fertile grounds for writing something. And at the time, I had been writing my own personal website in Node.js and Express, and I actually liked that a lot. mostly. Like, I like their setup. So soon after that, I started writing just like own little toy server, and it started getting bigger and more interesting. And it's not Flask, it's not Bottle, it's not Keg, but it's Growler. So Growler as in the beer bottle. Right, so it's written from ground up to use async IO. It's written by me and only me right now, so if anyone wants to fork it on GitHub, that's fine. I'm going to tell you it's not stable right now. I'm constantly changing things. But I can say with confidence that no one has ever gotten fired for using Growler, or for suggesting to use Growler. So I won't be able to say that probably in 2 days. But and right, it was inspired by Node.js's Express framework, which is a chain of middleware that you explicitly tell your application what to do. You can pip install it right now, and the goal is to have a bunch of extras that you can install alongside it. So if you want to use the Jade markup language, or Jinga. Wait, Jinga, is that the Jinja? I forget. Yeah, Jinja is the Python, Mako, etc. So I don't know if people actually know Express at all, but I'm going to go through it a little bit. And so this is JavaScript code. This runs in Node as the backend. And you create your Express object at the very top there. And then this area, you're using middleware functions. So presumably these are coming from somewhere else. And when a request comes in, when the client asks for something, it actually passes it through each of the middleware. It passes a request and response object to each of the middleware in order. So the first thing that would happen is this logger would probably just write log, oh, this IP address just hit you. Compression might add the ability for the response to compress all of its data. Get user probably gets a user from something, from the session ID in the rec, although I haven't said that we started a session, but beside the point. And then here, we have like an explicit one, so I can show you like the internals of what these look like. So at the top there, you see the request, the response. Next is the callback. So you always have to have a next in there if you want to call something else, because it doesn't know how long it's going to take for you to run. So whenever your function's done, it doesn't assume that your function's done. It might be waiting on something else. So you see here, if request has been given a user object, probably from getUser, we'll just store a username attribute from user.name. If you don't have that user object, or if it's falsy, it just uses the IP address with the @ sign. Or strudel character. I like calling it a strudel. I don't know about. When I heard that, I'm like, yeah, that's about right. It's probably not a good way to set a username, but beside the point. We can also modify the scripts object, or I'm sorry, the res object, and I added the scripts list, which I added jQuery, because why not? And then we call next, and then at the bottom there, you see these the router functions. So app.get, app.post, these are HTTP verbs that are going to be matched. There's also app.all, which matches all routes. And right, then you have the request path. So if your request matches just the root directory, the index, this function will be called. Actually, I don't have a mouse. Oh well. That function will be called and just say hello rec.username. We know that rec has the username because we added it in the previous middleware. If you didn't ask for just root, you asked for /username, it'll call that second function there. Or no, if you post to username, not if you get username, it'll just say 404. But the request's body, set it to user.name, send 200 to the response so everything is OK HTTP-wise. And that last listen there, that just starts it. And I like this. I kind of like how it's explicitly, it's not using magic. You're not just saying, all right, use these classes somewhere, and that's great. So right, explicitly. So get rid of all those. Now I'm going to show you the Growler application. And all right, I'm going to jump between them, actually. So I wanted to keep it as similar as possible. And I think I did a pretty good job. I mean, not that this was, I mean, I'm just, the interface. Rec-res, there's no next, because you don't need to call a next. If you need to yield from, you can make that a coroutine and yield from something, and you don't need to worry about callbacks at all. We have lambdas there at the bottom. Yeah, everything behaves exactly the same as I explained before. We have lambdas there at the bottom, which isn't, I mean, I don't think that's very nice. So we can put those in functions at the top there and then call those at the bottom. But actually, Python can do better than that with decorators. So if we just decorate all the functions with an app.get. Oh, typo. App, AP. Dang. Dang. Right, this works exactly as you'd expect with each of the decorated functions. So, design decision for, since I'm writing a server, which server method did I use? And I thought, oh, rec and res objects, this is perfect for start server, and this StreamReader, StreamWriter, might as well just like wrap them in request and response objects, and why not? Because I was new to this, and it turns out that it wasn't, well, at my experience at the time, I was getting, these readers and writers were getting lost. I was passing them to a parser, like to a request line parser, passing them to the header parser. I wanted to always like make sure that everything was clean, like that we weren't getting bad data, so that there was, data was always having to be called somewhere else anyways. So I went into this kind of, all right, switched over to the create server where I'm just getting data. I'm saying, all right, parser, parse this data, waiting for it to return something that isn't true, or isn't false, isn't none, excuse me. And it just responds to the events. Once all the data is read in, it'll respond by sending something back. Right, and in the original way, I had to implement buffers anyways to store all the headers. So now I'm going to go through like a little flowchart, active flowchart of how this protocol thing works. So at the beginning, before anything's going on, you have the async.io server that's actually listening. This is the coroutine running. You also have your application that you've set up with a middleware chain. Remember, there's only one application if you want one application. I'm sorry. There's one instance of an application for every application that you want. You could create multiple if you choose, but it's not creating a new application every time a connection appears. All right, so a client appears, sends a connection to the server. The server then creates a protocol. In this case, it's my Growler protocol. Calls init, calls connection made. Connection made, again, has the transport in it, so I can save that and write to it later. And then anytime the client sends data through the server, that's what that arrow shows, it calls data received on that protocol instance. And in this case, it parses the request line, parses the header, maybe parses the body if it needs to. And from here, we just create a rec and res object, which gets passed to the middleware chain. The middleware chain then loops through each middleware until eventually something calls res.send, sends it back to the client, and then everything dies, and the client goes away. Okay, did that make sense? Was that kind of, okay. So again, like, oh, is there one protocol? Like this, in this case, there's multiple protocols for every client. So writing the protocol, like you're responding with instances rather than like the class itself. This actually, like that demo was unacceptable for HTTP because it's extendable. And if you want to upgrade it with HTTP2 or WebSockets, or they send keep alive, so you'll have to send more data afterwards, what I just showed won't work because it kills everything right after res.send is made. So Growler had to fix that. And I fixed that with a responder stack. So I've created these responders as another method of indirection, which at the previous talk we all just learned is the best practice, is to add more layers of indirection, which for those of you online watching, you should check out Lars' talk, Well-Tempered API. So you can pause now, go see it. It'll be worth your time. I'll be here waiting. OK, anyway. So right, responder stack. So instead of the protocol handling all the parsing, I'm going to make a separate entity that will actually do the parsing and handle the on-data or handle the data received method. And I'm changing the name to onData because that makes a little more sense to me. I'm going to do another flow chart. So if this doesn't make sense, you'll see. So this modifies the behavior of your protocol by pushing and popping responders to this stack. And so we don't even need to use the middleware chain anymore because WebSockets might be doing something else. And any incoming data you don't want to be parsing as HTTP requests all the time. OK, so let's set up our situation here. We have a client. We created the protocol. When you create the protocol, now it has this responder stack, and that little square there represents that responder on the right. So now every time that this calls data received with some value x, Growler protocol forwards that directly to the responder with the onData method. That's where the parsing happens, and then you create your rec res there, and oh, that was OK. Play through that again, rec res, and then it proceeds as normal in this instance. In a different case, though, what happens if we got this upgrade WebSockets header in the HTTP? We pass the rec res, so that's all parsed properly, passed to the middleware chain. Eventually, it hits the WebSocket middleware that you've added, which stops the chain. It never... It just tells it to quit. Creates a WebSocket responder, and then, everyone at watch, it adds it to the stack. OK. So now, any incoming data, it looks at the top of the stack and will actually send it to the WebSocket instead of the HTTP parser Growler responder. So that was my solution. The other solution would have just been to, we'll just replace received data equals some other function, just like patch it, but I kind of wanted the ability to add more responders and then pop off if you needed to. I don't know, maybe you have XML and then JSON. I don't know, something. I don't know why you'd use that, but so after right, onData is called. Maybe it calls the application, maybe it calls the middleware chain. Probably does its own thing. All the power is yours at this point. So now you can hijack an HTTP connection with your middleware. If it requests a certain parameter, you can pass that to anything you want. So that's like the interface to Growler. And I think it's kind of cool. So let's switch gears and talk about middleware for a second. How am I doing on? I'm doing OK. So I have a couple standard ones right now. They mostly don't work, so I need help. Please, fork, pull request. So right, I'll just for example, so this renderer one, if you growler.middleware import renderer, it adds the res.render method to the response. So now you can call resRender and a template name, and when you create that renderer middleware, you give it the path to actually look for the templates. And so that's like a good example of how you modify this. And then Python actually comes with a cookie parser, so I'm just using that one with the cookie middleware. Static returns raw sessions. Sessions right now only use a Python dictionary to like store session IDs and data inside that. Probably not a good thing to do. So if you want to write a Redis session or MongoDB session storage, and auth I want to have like a common, like the canonical user authentication like ability where you say, oh, I want to enable persona, OpenID, anything that, any standard authentication method. But again, that's not implemented. It's going to take a little while to think about the design. OK, and there's one other cool thing. Oh, maybe there's a few. But one other thing I'm going to talk about right now. So if you have a class, so if you want to make an instance of some kind of application, like a blog, and we have these functions here, get index, get post by ID, get post by date, post new entry. And then we create our blog there at the bottom, and then we call these functions. We have to add these functions to the application. That's not very nice, though. That's kind of... what if we wanted more than one blog? Then you'd need blog 1, blog 2, and then call all those functions again. What if you change one of the names? You'd have to change it everywhere. You better hope that blog/ID keeps ID, or else you'll move it or else your function will be wrong, and all of a sudden everything will break because you changed it to UUID. I don't know, just that name. So I'm going to highlight here how we can get around this by I show you, all right, we already have the verbs. Like, we should be naming these verbs anyways. So if we have the verbs there, that solves one problem. The other problem is these routes. You know, we'd have to specify with arbitrary strings on a per function level, like what routes should call this function. And that's, you know, how can you do that? If only there was some way that you could add a string to a function that's unique. Oh, docstrings. So let's rewrite this using docstrings as the routes for this function. And so it says, oh, I need to get. This is a HTTP get. Anything with a get underscore, post underscore, put, delete, all will be picked up, checked for a docstring that has a route format. And how do we do this? At the top there, Growler router import routerify. So we routerify that blog object, and cool, automatic application created. We can use that on /blog. We can use it on /blog something else if you wanted multiple. The blog, I'm sorry, if you create a blog object and you app use it, it checks for if this is a router class. Oh, it is. I'm going to run through, find anything, add them as routes to myself. So there we go. Now you can just create any instance as these mini applications, plug them into your web server, and you're good to go. And right, that's only called when app used is there, so don't need to worry about it. It's not adding like extra complexity or changing your type or anything like that. Now, briefly, I'm just going to talk about what I've learned, like the big picture. Async I/O is not threads. That's one of those like no duh kind of like things that I've learned. Like, well, you knew that going in, but your code is not actually simultaneous. So as I've said that before, I'm just repeating now. You don't want to split your tasks into coroutines if they're all going to just require one another and not have any I/O. If it's going to take a while, you can use that run in executor function, which is nice. And right, creating a coroutine is not enough to run it. You must give it to the event loop, as I said multiple times. And the little words at the bottom told you that this is a coroutine, so you can't just run it. You need to add it to the coroutine, or to the event loop. Your current execution must stop and wait. Right, so this goes along with the everything. Only one thing's running at a time, unless you have threads somewhere in there. The other thing is to separate your application from the server. Originally, I had, like when you created the Growler app, you gave all the server information to the application, and then you called create server somewhere in there. That's not cool. You want to just give an application to a server that let the user decide how they want to set up their server. Put that code somewhere else. Oh, I forgot to mention actually, create server and start server. They both take host IP or host port and SSL environments, so you can automatic HTTPS pass in a HTTP, or I'm sorry, pass in an SSL context. if that's the case, you might want to create 2 servers, one on 80, one on 443. You don't want to create 2 applications, though, because it's the same backend. So separating your application from the server works. That's another reason. You create one application, you pass it to this server, you pass it to that server, and that should work. And remember, you get the socket, so you're not like losing abilities with that. And I'm just repeating myself again here. Don't make things that aren't asynchronous coroutines. You're just adding overhead. You're adding more complication. So why Python? If I'm just imitating Node and JavaScript, why Python? Why not? That's what, do you see something up there that you like? Maybe you do, maybe you don't, but there's a lot of reasons to like Python. If it's not libraries, then I don't know. There's also interesting projects, Brython, which allows you to put Python, it creates a JavaScript Python environment in the browser, so then you can use a script type text Python in your HTML. There's also the ability to transform Python into equivalent JavaScript, not an implementation of JavaScript. I haven't actually used either of these. I don't know how they work outside of, oh, this is what the doc said. But if you want to write client and server side in one language, you can also do it in Python, apparently. I don't know how well they work. But and I have one more slide here, the future. Kind of like the big picture, what I'd really want to do is have a remote service. So I said how we can turn a class or an object into this mini application. What if that was on a different process altogether? And so you had this blog, so you had the core server, you had a blog server running over there, and you have, I don't know, PhotoStream running somewhere else. And something's wrong with the blog database, so you just kill that server. Your whole, the whole site stays up. It might have a error handler that say, oh, the server, the blog's down, sorry, and a frowny face, but that would be cool. So if you could just Unix socket them in, and that's what I'd like to see happen. Or if someone else wants to use it for another thing. Maybe it already exists. I don't know. I haven't done so much research. I've just been thinking about how to do it. You need to pickle the request and response objects and send it, but that might be kind of difficult. I don't know. OK, and with that, thank you for listening.
Question.
So did you use run and executor at all for Growler?
No, not at all.
When would you use that versus wait until or run forever on the loop itself? What would be the advantage?
What would be the, well, run an executor would be just some other task that you'd have to, something that's going to take a while, they uploaded some file and you're going to, we saw the lightning talk yesterday where they had the file, the picture, and then they added the words to it, so there's image processing in the background. That's going to take a little while, so you just add that to your event loop. Yield from run an executor, insanity wolf, text, and then the event loop will pause. The event loop's still running in forever anyways, so that gets scheduled. It'll eventually happen after everything else in front of it is processed, or it's eventually returned. It's always happening in the background with run an executor, not any other code.
Is it harder to communicate with the function you throw in the executor than it is with the coroutines themselves? Like how
Right, you don't want to do that. That's going to create deadlocks.
Okay,
I think you'd need to manage locks and mutexes. And there are semaphore classes, there are things like that, but I haven't used them at all. But yeah, run an executor looks pretty cool.
Is executor multiprocessing, or is it actual Python threads?
Ooh, it's concurrency. It's Python concurrency. So that's a module. That's a not submodule, but that's part of the standard library is a concurrency library. I didn't know about it, but so it's whatever that uses, and it's probably Python threads.
So it would be subject like the GIL, maybe?
Yeah,
Okay.
I would imagine so. Hooray.
Other questions? Anyone? All right. Thank you so much,
Okay.
Andrew.
All right. Thank you for having me. I have one more thing, which is async. Thank you. Thank you.